This is problem 2 on practice exam 7 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. Whoa, that's a lot of text. So you're in the freshman physics lab and you have to calculate 10.3 squared. And the others reached for their calculator and you said, look, it's about 106. And they looked at you like, yeah, right. Let me just check it. And they started to punch the numbers in your calculator and you said, look, if you want to know exactly, it's 106.09. And their calculator said 106.09. And they said, how can you do that in your head? And he said, well, look, 10 squared is 100. So 10.3 squared is a little bit bigger than 100. And we know how much bigger it is than 100 because of differential calculus. That's what differential calculus is about. It tells you how a function changes when you change the variable. Here the function is x squared. If we start at 10 and go to 10.3, we know how 100 or 10.3 squared changes. It changes by 2s delta s. And if you want to know exactly, you have to put in the s squared. And if you look at the square, you can see exactly what's going on. There's the original side of the square, 10. Then you add the 0.3 on. This goes all the way to 0.3. When you add the 0.3, the changes are a 10 by 0.3, which is 3, a 10 by 0.3, which is 3. That's s ds. S is 10, delta s is 0.3. And then you have this little square. That's 0.3 times 0.3, and that's 0.09. So 10.3 squared is 2 s ds's, 2 s delta s's, which is 6. And if you want to put that in, you can. But you don't need to if you're doing a physics lab, that's for sure. So let's do some estimates. 1,004 squared. Can you picture a square that's 1,000 by 1,000? If you have a square that's 1,000 by 1,000, that's a million. 1,000 times 1,000 is a million. So 1,004 squared is bigger than a million. And it's bigger than a million by 2s delta s. And if you want to put the delta s squared in there, the little square term in the corner, you can. So let's do that. It's a little bit bigger than a million. Differential calculus will give us the answer. A good approximation, if the change is small, is 2x delta x. So x is 1,000 and delta x is 4. So that's 4,000. And we multiply by 2 because there's two rectangles there, and we get 8,000. So we know that 1,004 squared is 1,008,000. Very close. Now, if you want to put that little teeny square in the corner, you can. In the upper right corner, it's 4 by 4, right? It's delta x squared. So if you want it exact, it's 1,008,016. You should do that on your calculator. Part B asks for an estimate of 30.2 squared, and we know 30 squared is 900, so we know 30.2 squared is 2x delta x bigger than 900. 2x delta x is 30, delta x is 0.2, we get 12. So it's about 912. The exact answer, you have to square the 0.2. It's 912.04. Check it with your calculator. 6.015 squared. So that's a little bit bigger than 36. How much bigger is it than 36? 2x dx. X is 6. Delta x is 0.015. So 2 times 6 times 0.015 is 0.18. So 6.05 squared is 36.18. Pretty close. You have to put the square in the corner. 0.015 squared is 0.000225. So you can put it in if you want. 36.180225. Do it on your calculator. Part D asks for an estimate of 7.99 squared. That's a little bit different. It's a little bit less than 64. How much lower than 64 is it? Well, it's 2x delta x. Same thing. Delta x is negative here, negative 0.01. So we start at 8 and we go down to 7.99 by subtracting 0.01. So 2x dx is minus 0.16. So 7.99 squared is very close to 63.84, right? 63.84. Yeah. And if you want to put the square in, you can. Go for it. Explore. Figure it out.